Section 6.3, Complex Rational Expressions. A complex rational expression is a rational expression that contains a rational expression within its numerator and/or its denominator. When we simplify a complex rational expression, we rewrite it so that it has no longer a complex state to it. We will consider two methods for simplifying complex rational expressions. The first method is to use the least common denominator of the rational expressions within this complex rational expression. So in this first example here, the denominator and the numerator is 5. The denominators of the denominator are 3 and 15. The least common denominator is 15. So we will multiply both the numerator by 15 and the denominator by 15, which is ultimately multiplying by 1. 1/5 times 15, which is understood to have a denominator of 1, is in the numerator. The denominator we need to distribute will have 2/3 times 15 plus 7/15 times 15. Well, 15 over 5, or 15 divided by 5, is a 3 in the numerator. This 15 has a denominator. You can either multiply 30 divided by 3 or cancel out 3 divided by 3. 15 divided by 3 is a 5. 2 times 5 gives us a 10. And 7/15 times 15, which is over 1. Canceling out the 15s, common factors is a 1, leaving us 7 times 1, or 7. Simplifying further, we have a 3 over 17. There's nothing common. And who knew that this complex rational expression was actually the same as 3/17? We can do the same thing when we have rational expression that has variables in it. Using that same technique, we look at all of the denominators. We have an x, y, and an xy, so our least common denominator of all the denominators is xy. We will multiply the numerator by that quantity and the denominator, and xy over xy is equal to 1, so we're not changing any value, we're maintaining this. Distributively in the numerator, we will have xy times the first fraction of 1 over x minus xy times the second fraction of 1 over y. In the denominator, we have 1 over xy times the xy. Well, the xy's have denominators of 1. When we are multiplying fractions together, we can cancel out common factors. The x's cancel out, leaving us with 1 times y over 1, or y. In the second term, the xy is over 1. We have a common factor of y in the numerator and in the denominator. They cancel out. Same value over the same value is equal to 1. So we have an x times 1 divided by 1 is x. And in the denominator, this xy over 1 cancels out the xy in the denominator, leaving us with a 1 times 1 divided by 1 is 1. Anything divided by 1 is that thing. So our simplification of this complex rational expression is y minus x. Another method of simplifying a complex fraction is to rewrite the expression as a quotient of two rational expressions. When you have the numerator and the denominator as single rational expressions, and we do, we have a rational expression, or call it a fraction over a fraction, we can divide the numerator by the denominator. So instead of expressing this as a complex fraction and recognizing this fraction bar represents division, we can write it, instead of a vertical division, we can write this as a horizontal division. Top rational expression divided by bottom rational expression. And when we have division of fractions, we leave our first fraction or rational expression as is, but we turn our division into multiplication and we invert. So we're inverting and multiplying. So we have a binomial times a binomial in the numerator and likewise in the denominator. We look to see if there's any common term, in this case a binomial, in the numerator. Nothing matches up. And the best form to leave this is as is in its factored form so that we can look and determine very quickly that this is a simplified rational expression.